Hello, everyone, and welcome to the webinar on DCAM Cut, which will be given today by Mirko. Before we start, Eddie, if you want, you can say a few words now.
Yes, Sydney, thank you very much. First of all, thanks to all our attendees today for this webinar about Wirecut solution from our partner, DCAM. So what is important for us is that you will know when you meet the deal, when customer has many milling machines, mill turn machines, turning machines, but also has customer one or more Wirecut machines, you have to know that you have qualified solution, very strong solution for these prospects, for these customers. So don't leave this deal, go to fight with SolidCAM and if needed also with DCAM to win every deal you meet. And what we will make today, Mirko will show you this solution. He will explain you the differences between different packages of DCAM. He will let you know about their post-processors, about their support of Wirecut machines. They have very, very good and advanced support. And we'll show you some examples and new things which were released with latest DCAM Cut version. So enjoy the webinar, and you have to know that also for this solution, we have a good support, we have good product, and we will be there to support you in all you need to win every deal. So enjoy the webinar, ask all questions you have through the webinar, after the webinar. We all here to support you in all your deals. Thank you very much and enjoy the webinar.
Okay, thank you, Eddie. Okay, I'm going to make Mirko Jovic the presenter. Mirko is one of our application engineers whose expertise actually is in DCAM Cut. So go ahead, Mirko. You are now the presenter, and I will unmute you, and you can go ahead and speak.
Okay. Hello, everyone. As Sydney said, my name is Mirko Jovic, and I'm here today to present you a DCAM. In most cases, we will talk about product edition review. We will talk about post-processor support, what's new in 8.3 version, and we will talk about technology database. First of all, I wanted to tell you that me and my team can fully support you in your every DCAM problematics, and you're able to have the support like in SolidCAM support. We will start now with our product edition review, and we will start from the basic one, which is DCAM Basic Plus. As you can see here, we have a few features which allow us to make the toolpaths, and I will explain you one by one meaning of every feature. So the 2D contour allow us to define all our jobs and through the arcs, sketches, solids, and surfaces. Therefore, we are able to create 2D jobs. And next one will be two-level contour. This is a feature where we can create 4-axis operation via 2 sketches. And now I will show you how you can do that very easily. And as you can see, I already predefined some sketch, which I have a lower contour, upper contour. It's a circular contour, and I broke it in entities. And I have guidelines. And now I will show you how to create 4-axis operation with the 2 sketches. Okay. Basically, this is something like a loft operation inside the SolidWorks. And I will define my contour, and here I will select by 2 levels, and I will select geometry. Here I'm able to select all, and I will just hit OK, and I will select my reference lines. I will select this one, and I will select this one. Now, the important thing here is to see the direction of the sketches. Therefore, I need to change one of my 2 directions, and I will do in just simply with the checkbox here, reverse derivative direction, and I will hit apply. And as you can see, we have created surface which show us our contour that we created. And now I will start creating the operation, which is very easy, and this is the workflow that we will follow from now. And I will select start element and distance. This is a type of borehole, and I will select my first entity where I want to put my borehole. I selected the line, and I will select distance of, let's say, 10 millimeters. And I just need to see on which side my borehole is, which is presented as a red dot, and I want to go from outside, and I will just checkbox this punch, and basically I will increase distance, and I will say apply. Basically our borehole is done. What we need to do now is to create contour template. And as you can see here, we have few checkboxes that allow us to control some features that will define our contour, which is approach and retract, interpolation, distraction, quality, technology, offset, and in events we have NC code, and rotation and axis rotation for our indexial and simultaneous job. For now we will use only a few basics, and I will use approach. I will leave it as it is. It will be perpendicular approach and retract. I will interpolate this contour. I will select my quality from my quality list for material and this wire. I will OK, and I will select the default technology, and I will hit apply. I will hold on for a few seconds, and now you see that we have created our toolpath, which is very fast, and I will define my job, and basically this is all. That's all. We are able to run the G-code. Therefore, this is a workflow for creating the toolpaths inside the DCAM, and as you can see, this is a very fast and very smooth while creating those operations. And the only thing that we cannot do is we are not able to create the complex geometries with this ruled surface machining, but I will show you how to do it in a few minutes with the complex contours. The next feature is a parametric processing, which is synchronization between the reference model and our EDM jobs. When we change our reference model, our jobs will be automatically synchronized. Therefore, we will not lose time to make new operations, and we have automatic update. Next one is a feature recognition, which works very nice, and you have it in all 3 products. And this feature recognition make our job very easy, and with a very nice filter we can tell what we want to achieve, and everything will be done in matter of seconds. Also, we have templates which we can predefine in some operation, and it can short our time in programming, and we can define our contours, jobs, and program templates. And also we have standard simulation, which include offset surface calculation and visualization, which is a basic type of simulation. The next edition is DCAM Professional, which is a bit advanced, and as you can see here, I make some split that includes the basic edition and some additional feature that comes with the professional edition. And as you can see, we have NC browser, which is very nice feature, which allow us to generate the G-code and to see the G-code without exiting the software. And I will show you how. Okay, I will give my file name, and here is my output. I will select OK, and as you can see here, I have the G-code, which can be also selected and copied, but it's not able to be changed in order not to create false geometry and false toolpath on your machine. The next one will be solid simulation, which can show you actually your stock and your 3D contour that runs around your stock, so you can see actual cutting. Also inside the solid simulation, you can see your devices attached on your EDM machine, such as the rotational axis inside erosive grinding and your table inside multi-axis EDMing. Also, there is a slug checker, which checks your slug removability, and the software will automatically tell you is your slug extractable or not, which is very nice feature. And if it's not extractable, you need to create additional operations in order to extract those slugs. Next one is approximation, which allow us to convert some arcs, lines, splines, etc., into the small entities and lines in specified tolerance. And why we need approximation? We need it because many machines do not run in 4-axis with arcs and circles. Therefore, we need to interpolate those segments in order to run the machine correctly. The next feature is a 4-axis pocketing. This is very nice feature which allow us to create slug-free, let's say, dies. And therefore, we will not need operator to remove slug. Our machine will not stop if we have slug to put magnets, etc., and we will create much faster job than the regular contour programming. The next edition is DCAM Expert, which is most advanced edition from our solution. And as you can see, we have basic and professional edition included, and we have few features that are very, very nice, which can be upgraded inside the DCAM Expert. And those features can be erosive grinding, which is a very advanced technology of the wire EDM cutting. Also, we have simultaneous multi-axis machining. We have multi-plane machining. It's indexed machining. And we can upgrade solid simulation, and we have an option for post-processor upgrade in multi-axis machining. The next one, the next title is post-processor support. Our solution provides us very huge database of the machines itself, and basically 99% of the machines are covered by certified posts from the DCAM, and therefore you should not be afraid if they ask you for post-processor. 99% that we have that post-processor, and the main thing here is how properly to pick your post-processor, and now I will show you how to do that. In the first tab you have drop-down menu, and the first one is machine. Here you have machine manufacturer, and now we will choose one of them. Let it be RG. Here in next drop-down menu we have machine controller. Therefore we choose our post-processor by choosing the machine manufacturer, controller, and machine at the end. And here you can see we will choose CNC 123, which is one of the oldest types of the machines. And here in this tab, inside the configuration, you will choose your machine model. Okay? And basically this is proper way how to choose your post-processor. The next content is what's new in 8.3 version. Okay, I selected few features that can be very interesting for you, and the first feature will be tool for geometry check. This tool allows you to create small report about your EDMable surfaces. Therefore, you are able to see the most important one is to see your deviations of your faces, and with this tool actually you can check your design department if you have one, and you can see in what tolerances you will actually create your contour and your jobs. Also, you are able to see minimum maximum length of the contour, minimum inclination and maximum inclination angles, etc., etc. So this is a very nice tool which provides you very accurate data. And as you can see here in this picture, we have spline deviation with a measurement that we cannot even measure it. But it's important to have it, and it can release you from some problems in the future. Next one is simulation. In this version, simulation are fixed, and there is no more suddenly jumping of the part while simulating, and the zooming are much more smoother than before, which I will show you in few minutes when I open the next part. The next feature are 4-axis destruction offset algorithms. Those algorithms, as I said before, are very advanced, and they are very nice to use if you want to create your slug-free dies in order not to waste your time and to save your money from not paying extra hours for your operator. There is 4 algorithms that can be defined inside the 4-axis destruction offset, and I will start showing you one by one and show you the differences when and how to use those algorithms. Now we will start with successive offset algorithm, which is basically this algorithm offsets your contour in numerous times in order to create the destruction. pocket. Okay, this algorithm can be used also on open edges, which is a very useful when you have some kind of punches that you are unable to extract in one way. As you can see here, we have this punch, and in this order, because we have two reversed lofts, we are not able to remove it with a single cut. Therefore, we need to release those lofts so we can extract this part without any problems. And now I will show you why we need to create our release and how to do it. First of all, we will go to define our contour, and I will select, inside the options, I will select just geometry here, and I will select this solid body. I will select OK, and I will just hit apply, and DCAM will do the rest. Now, as you can see, we have our contour, which is very nice, and I will start defining my borehole, and it will be start element and distance, which is my favorite. Okay, and as you can see, we have surface that present our contour, and I will select element where I will put my borehole. I will wait a few seconds, and now I will take him distance of 5 millimeters, and we will just check on what side our is. We will reverse it. Okay, and I will apply this, and I will start defining our contour template, and I will define my approach. I will interpolate, I will select my quality, and I will select my technology. I will hit apply, and as you can see, our toolpath is ready to be created. And here I will simulate this. Now you will see the solid simulation. And as you can see, we have stock, and we can set our stock transparency, which is a very nice feature. And as you can see, our simulation are pretty smooth. And I will run our simulation now, and you see we get a warning from our slug removal, unable to calculate direction for slug removal. Therefore, our slug or our punch or die are not able to be removed. In order to solve this problem, we have solution for that, and what we can do, I will leave this contour, and we can create new contour, and I will say open contour, and I will select my reference elements, and I will select this one. I will wait, and I will select this one. Okay. And here I just need to change my direction, and I will apply. And here, now what we can do here, we can create our contours from segments with this contour, but we will not do that. We will define another geometry, and I will show you now how to select the whole side. Okay, and here I will just wait, and that should be it. and this one. Okay. Okay, one more second. I will just reopen the part. And as you can see here, we have created our offsets, and here I will simulate how we can remove this unnecessary material around our lofts, and we will be able to generate without any problem G-code and to run our, as you can see, we have offset. We have small slug here, and we will continue. And as you can see here, we can easily release our side. Now what we have to do is to create another contour, and I will do it automatically. And here you will see I will hit OK, and I will just apply. And now I will select my borehole and do as in previous operations. Okay, I will set my distance to 5 just to see the direction. Direction is good, and I will select OK. Now we have contour templates. I will select approach, interpolation, quality, and technology. Okay, I will hit apply, and I will just simulate those two operations, and you will see the result. We have 4-axis pocketing on open contour in order to release this side. We have 2 small slugs, and now you will see that we released this, and now we are able, we need just to increase a bit this offset, but we are able to remove this slug easily. Okay, next one is a slug cylindrical kernel and spiral destruction. I will show you these 2 kernels in order to show you the differences between both of them, and I will show you the differences on one part. Okay, we have extrusion die here, which is a long and which is a very thin. And as you can see here, we have small circular as an exit, as a lower edge, and we have ellipse on the upper edge. And we will start defining our contours. I will select, and now I will select my filter, which is very useful thing that can help us a lot, and I will uncheck these outer contours, and I will select geometry. I will select my die, and I will hit OK, and I will just apply this. Here we have a die. We have nice blue surface around it, which means that the contour is generated. And now I will define my borehole, and here I will define the borehole with a predefined borehole geometry. And I already made this circle, and I will select this circle. I will hit OK, and our borehole will be in center of that circle. I will hit apply. Okay, and I will start with my contour template, and I will unzoom a bit. Okay, I will define my approach. It will be perpendicular. I will interpolate this part, select quality and technology. I will hit apply. Okay, and I will hit OK. And now, in order to see our destruction solution, and when you need, you can run this part to be slug free, and you will not have slug, and it will take a bit more time, but DCAM works on optimization of the toolpath, and therefore there will be minimum waste of the wire and maximum engage of the wires. Therefore I will show you now, and here we have destruction cut. The good thing that those parameters we can directly choose it from our quality. Okay, and you can see that we have some data which came from our quality list. And here we can choose our algorithm, and the first one we will use cylindrical kernel. Cylindrical kernel means that in this algorithm we need to have one concave geometry, so it can be upper or lower. In this case this will be a lower, and I will just apply this, and you will see the toolpath. Okay, and as you can see, you will see now, you see that our toolpath is made a circular toolpath, and when the lower contour is done, then it's morphed around this ellipse. And let me just simulate this in order to show you how it works. Okay, second, I will simulate. Okay, and I will switch it on the lower side, and I will increase transparency just to. Okay, you see this perfect circle, and after circle you have your ellipse morph. Okay, we have semi-finish and finish, and basically this is the circular kernel. And now I will switch my destruction to spiral destruction, but here I will create the new contour group. Okay, I will use the filter now, which is very useful for us, and I will just select my geometry. Now the spiral algorithm allow us to not waste too much wire, because this strategy allow us to achieve much more contacts between wire and your die, and therefore you will have nice cutting condition and your wire will be 100% used. This is the purpose of this strategy. Now I will define my borehole. I will select, as in previous case, I will select my sketch, and I will simply apply this. And here I will select everything as in previous operation. I will apply. And now we have simple contour, and I will add my destruction. And as you can see, I will select my spiral, and I will take my parameters from quality, and I will just hit apply. Okay, this warning means that there is too many cuts and the paths are hidden in order to save our performance on our PC, which is very, very nice feature. And I will show you now the toolpath, which is not like a cylindrical kernel, but the engage of the wire in order to make smaller toolpaths are generated. And now you will see the toolpath. I will reduce the speed. As you can see here, the circles are not maintained. And this simulation can take a while because it's made from small segments, but as you can see, our wire engagement is all the time constant, and this is very nice feature for 4-axis pocketing. I will stop this simulation, we will not lose our time. And the next one is slug-free subdivisions. Okay, this is very unique feature which allow us to create our pockets by some segments. So we can split our part to be machined with various pockets. And as you can see here, this is a 4-axis part with a 2 degrees inclination of the face. And I will show you now how to define your subdivision group, and I will go to define my contour, which is very, very easy here. I will use my filter again, and in matter of 3 or 4 clicks we can generate our contour. And I will apply. We have our contour, and I will define my borehole. Okay. I will hit apply, and I will start defining my contour templates. I will select approach, interpolation, I will select my quality and my technology. Okay, few seconds to wait. Okay, and as you can see here, we have very nice 4-axis contour, but what I want here, I want to do these small regions here in pocketing. So what we will do here, we will go and define our destruction cuts, but we will use slug-free subdivision. And as you can see, we have 2 segments here, and we will just check box for partial, And what we will do here, we will select our regions. And the tool that we need, the thing that we need to make to select different regions are basically two small surfaces that we define from sketch. And I will select this surface and I will select this surface. And I will apply it and just hit apply. Okay, they are not displayed, but we have offset here. I will hit OK and I will create the job and we will simulate in order to show you the pockets. This is very powerful feature if you have, let's say, some segments that are maybe those leads inside the regions are thick as wire, and the best solution is to create this kind of operation, because you will not need to stop your machine to put your magnets on and so on. And now we will see how it runs by simulation. Okay. You see this is a 4-axis pocketing. You see the wire inclination. The nice thing is that DCAM can also automatically recognize those small features, but in this case we will use it manually. So next time we will show automatically. Now you see the pocket is almost done, and it will do the semi-finish. And now it will start running the second and smaller. And as you can see, now it will run for finish. And you will see that we will have a huge slug, but in those pockets there is no slug. And you are able to see now. As you can see, we have slug without those two segments. Okay. So we are done with the 4-axis destruction offsets. The next one is a bore list, which is very nice feature, and it can save us a lot of time. And as you can see here, we can create small documents that can be used by operator, and those borehole list or start point list contain the coordinates according to the coordinate system that you used. Where should you drill your hole? And also there is a diameter of the hole, so you can fully define your technical drawing and you can work without any mistake. Also, you can output the picture, the paths time, technology, and cutting sequence, which is very powerful and very useful in all kinds of shops. The next one, the next content is what's new in 8.3 version. Now we will talk about erosive grinding. This is advanced technology of the wire EDM cutting. Basically, this is a turning. This is a turning on the wire EDM machine. When we use this technology, we use it when we need to create some parts that we are unable to use the lathe and the lathe operations. And when we have thin walls in grooving cuts, etc., we will use our erosive grinding option if it's available on our machine. And now I will show you, I will not program the part, we will be running out of time, but I will show you the part, how it looks like, and I will show you the simulation. I think that you will be really amazed with this feature. Okay, this is the part. This part is not that big, it's 10 millimeters in diameter. Here we have around 1 millimeter, and this is not possible to do on lathe. And here I will simulate my job. I will simulate all jobs. One second, sorry for this. Okay. And now you will see some part of indexial machining in combining with the turning and simultaneous VDM machining. And as you can see, it's a fully supported with simulation. I will reduce the transparency, and we have 4-axis pocketing. Here we had indexial pocketing, and we have simultaneous operation. And as you can see, our part is done. And it's pretty the same as our model. Therefore, this type of technology are very powerful, and this is a high-end technology. Therefore, you should not be afraid to accept these challenges with your customers, and it's good to know that you have nice solution like this. Okay, the next one will be technology database and quality. Our solution offers us excessive cover of qualities and technologies according to wire and machine type. This is very important when your customer have AGI machines, and it's very hard to create technologies, but the DCAM offers us huge quantity of the technologies which can be easily edited according to your customer's request. Even your customer can edit every technology or create a new one, and the main thing that all parameters are covered with this technology and qualities. And if you have any more questions, please don't hesitate to contact me. We are done for today, and I will ask Sydney to take over, and I will expect some questions.
Okay, Mirko, thank you very, very much for the very informative webinar that you did today. At this point, there are no questions, but everyone can always send their questions in, and they'll be forwarded to Mirko as well. The webinar has been recorded as usual and will be available on our website. And just to show everyone that on our website, if you open up our website itself and you log in under your name, if you go to company, we have the area over there for resellers at the very bottom, and in the reseller area we have all the reseller webinars just by clicking on it, and you can see every single webinar that we've done is over here. So if you want to know where to find the webinars, you can see them here on our site. Okay, thank you everyone for joining our webinar, and have a great weekend, and we'll see you at our next webinar.